Good morning, ladies and gentlemen. Today we're looking at surds, largely a recap of work in Year 9. On the screen in front of you are surd laws that you'll have seen in Year 9 but are good to have down in your reference book. Today, very quickly, I'm just going to go through examples of using these surd laws and then you can do another quiz. So, simplify. Now, when it means simplify, it means collect every like term we can together and simplify down any surds. So if something's written as the square root of 100, you're thinking, well, really, I can take something out of that and simplify it. Simplifying that would be, well, let's look at square root 4 times square root 25. The reason we've done that is because, the reason we can do that, 4 times 25. Now you're probably thinking, well, why didn't we do 10 times 10 or 5 times 20? The reason I didn't go with either of them is because both of these are perfect squares. Sorry, that was a terrible example. Square root of 100 is just 10, isn't it? Let's try a better one. Square root of 100. What are you doing? Square root of 70. 72? 72, sure. I would take that to be square root of 36 times square root of 2. Square root of 36 becomes 6. Root 2 we can't do anything with. This is the simplified version of that. Root 100. Alright, so one of the rules is we can collect like terms involving surds. So that reads as 5 lots of root 6, and that is minus 2 lots of root 6. 5 minus 2 is 3 lots of root 6. Similarly, 4 lots of root 11 plus 3 lots of root 11 is 7 lots of root 11. Now we can't simplify the root 6 or the root 11, so we leave it as that. Alright, here. 3 root 49 plus 2 root 288 plus minus root 144. Some of these you'll recognize as perfect squares already. For example, root 49 is 7. So this here really reads as 3 times 7. Now, plus 288 could be written as the square root of 144 times the square root of 2. Minus the square root of 144 minus 2 times, now root 18 could be written as root 9 times root 2. So it's a matter of splitting these surds into things that will help us. The reason I've split them in like so is because I know square root of 144 will be 12, and I know square root of 9 will be 3. So I realize there are other ways to factor 288, but we choose the most convenient one that pulls out a perfect square number. So, starting off, 3 times 7 is 21, 2 times root 144, root 144 is 12, 2 times 12 is 24, plus 24 lots of root 2, take root 144 is 12, take 2 times root 9, root 9 is 3, so 2 times 3 is 6, root 2. Now, collecting like terms. Like terms are the root 2 terms and the integer terms. 21 take 12 is 9. Then we have 24 lots of root 6, take away 6 of them, we're left with 18 lots of root 2. Sorry, I said root 6, root 2. And that's as simple as you can go. Alright, multiplying. Now, multiplying, it helps us to consider this as multiplying in any order. And recall that if we have root 3 times root 3, that just becomes 3. So we'd really like to set up things like that within the multiplication because it makes it simpler, like this. Alright, so I would rewrite this. I wouldn't rewrite an actual test, but for an explanatory purposes, we can rewrite it like that. Now, 4 times 2 is easy. We're just going to leave that as 8. Root 15, I could write as root 3 times root 5. In fact, I may even write that the other way around. Root 5 times root 3, although no, it wouldn't matter because you can multiply in any order. Times. Now, with root 18, you could go 2 ways. You could either go root 9 and root 2, and that works quite well because root 9 disappears down to a 3. Or you could go root 3 times root 6. In the end, you'll work out with the same answer. These things have a way of dropping out. So this then becomes 8 times, now this root 3 times root 3 becomes 3. And we'll just fill in the blanks between it. Alright, now 3 times 8 is 24, so you can collect the normal ones. That's times by root 5 times root 6. Now root 5 times root 6 is root 30. 24 times root 30. What can we do with root 30 and pull out of root 30? Not a lot, really. 2 doesn't work because you get a 15 on the other side. 3, you get a 10, doesn't work. 5, you get a 6. No, leave it at that. That's our answer. 24 root 30. And note, I know your calculator can simplify this in the blink of an eye, and by all means use it to check your answers, but these are questions you clearly should be able to do mentally, and therefore they're the type of questions that will be in the non-calculator section of exam/test. Alright, 2 to go. Once again, we're going to look for common bases, or common roots. Now here, it happens that root 3 drops out again. That will be the same as negative 3 on 9, root 3 times root 7. Root 3's cancel. This leaves you with negative 3 on 9 root 7. Then you can cross that out and that becomes remainder 3, which would leave you with negative 1 over 3 root 7. Note you can leave the negative right out front of the negative of the fraction sign like that. Most oftenly, because it works algebraically nicely, we associate it with the top. Either way is fine. What you cannot do is see it here and think that's the same as a negative and a negative. It's not. Having the negative out the front doesn't imply negative to both top and bottom. It's negative to one of them. You can either treat it on the bottom or on the top. Normally go the top, but it doesn't matter. Alright, last one. FOIL works, so does n, distributive law expanding brackets. So this expands in there. 4, then root 5 times root 5 is 5, minus, then this one here, the root 10, I'm going to treat the root 10 as root 5 times root 2. Alright? Therefore, you'll have it written as 4 times root 5, that's coming in from the outside, multiplied by root 5 times root 2. From the outside, from the root 10. So, 4 times 5 is 20, minus 4 times root 5 times root 5. Well, root 5 times root 5 is 5. 4 times 5 is 20 root 2. Simple as we can go. Can you please, once again, log in with your own name so I can see who's done it? Do that quizzes online. Thank you very much.